Today's day 4 of Unit 9 on solving quadratic equations. Last night's homework was to simplify radicals and leave them in simplest radical form. So make sure that you are checking that you have exactly my answer. There is only one solution. For example, I don't think any of the for number 3, there were a couple different perfect square factors that you may have found earlier on. So make sure that you have the simplest form. Remember, I told you even if, so let me write an example. So right here I have an alternative example. If you chose to go with radical 16, you also could have done 4. So if you chose a perfect square that wasn't the largest perfect square, you would have still had a radical that you could further simplify. So 12. Another popular one, radical 8. Radical 8 has a factor of 4. So look for those factors of 4 when you have your radical, because again, you don't have to start over, just pick up where you left off. So if you notice that you got to here, well, it's not in simplest form, so just keep going. So you don't have to start over, just keep going and use the methods that we did, for example, for number 2, for number 5, for number 6, where at the end you have to multiply those coefficients together. So again, it's kind of like simplifying fractions, right? If they both are even in the numerator and the denominator, keep dividing them by 2 until you get down to simplest form. Alright, so yesterday you may have wondered why on earth we were simplifying radicals. What does it have to do with solving quadratic equations? Well, think about it. Our quadratic equations always have an x squared in it, right? Our standard form is ax squared plus bx plus c equals 0. I also showed you in the last chapter that our roots, our zeros, are not always going to be whole numbers. So this is where simplifying radicals is going to come into play. So the steps that we're going to be doing in all of our examples today are as follows. So we're going to isolate the x squared on one side of the equation, okay, and that will leave a number, a constant on the other side. And then we're going to take the square root of both sides. Okay, so if you think about it, okay, so if we have 4x is equal to 8. So this is a multiplication problem. So the opposite of multiplication is division, right? Well, similarly, okay, so we'll do that times 1. Similarly, if I have x squared is equal to 1, I can take the square root, and that's how I solve for this. Okay, so I'll further explain this on the next page, well, on the next part. Okay, so before we get started, it's important to think of to talk about one big concept. So if I take the square root of something, okay, I'm asking myself, what could x possibly be to get to 4? So the square root of x squared is x. And you might be saying to yourself, the square root of 4 is 2. But it actually could be positive or negative. Okay, so let's think if we check back. Okay, so x squared is equal to 4. So that means that if it's 2, it equals 4. But also, if it's negative 2, it will also satisfy that equation. Okay? So your answers are always going to have a plus or minus in front of it. Okay? So you'll see that as we go. So let's start with something nice and easy. So we have x squared is equal to 32. So we're going to simply take the square root of both sides. I was going to get an x on this side. And now I have to simplify this radical. Okay? So I'll rewrite radical 32. So I'm going to think of my factors, all right? Hopefully you're thinking 16 and 2. So I'll separate them. Again, the only thing you're adding now is the x equals. But the other thing we have to add is that plus or minus. Okay, so every time you take that square root, you're always going to put a plus or minus in front. All right, so think about it. You're always going to have two answers for this. Okay, if you were to put this in your calculator, and I'll explain that in a minute. Okay, so this is my final solution. So these would be my my roots. So I'd have 4 radical 2 and negative 4 radical 2, if you want to put it in that form. Okay, and that's really all I'm looking for. Okay, so let's try another one. Okay, now this one, if you want to put that in your calculator. Okay, so if you put number 2 in your calculator, you see, and I know my window is too small, but you can see that it passes through here and here. So there has to be two solutions. All right, that's why you're writing plus or minus. So every time you take a square root, you always have to put plus or minus in your solution. A little less worry. Okay, so the first thing we're going to do is we are going to isolate that x squared. So we always want to have x squared by itself. And next we're going to take the square root. So now you go in your calculator. Remember, this is going to be plus or minus. So now you go in your calculator and you're going to start dividing out perfect squares. Dividing out perfect squares. This one again is radical 16. So my final answer is 4 radical 6, and I'm done. Okay, now this one has the 56 on the other side, but there's a 2 as a coefficient. So, again, isolate that x squared. And square root it. My solution has to have a plus or minus. 4 and 7, I think, is as simple as we can get. So my final answer is plus or minus 2 radical 7. Okay? And that's really all. So on the next one, they want us to use the equation, and it just so happens that this worked out. I actually can't read this graph because you can't see the lines. But most of the time, and as you can see, these are when your zeros are equal to a decimal. So instead of rounding our decimal, if you actually write it in simplest form, in simplest radical form, what you're doing is, you're actually making it more exact than if you were rounding. So simplest radical form, and again, always got to look for, that's what they'll ask you for if they want you to use a square root. Okay, that's the word you're looking for, simplest radical form. Okay, so I'm isolating that x squared, so I need to get rid of, so think, it's no different than if you were isolating an x. Okay, the only difference is that there's an x squared. Okay, so we have 1/2, remember the opposite of 1/2 we can multiply by the reciprocal, or you divide by 1/2. So I'm going to multiply both sides by 2. So 8 is equal to x squared. Square root both sides. So I get plus or minus the square root of radical 4 and radical 2. So x is equal to plus or minus 2 radical 2. Now if you're asking yourself, why did I just flip the sides? Remember, it's an equation, so you can always do that. Only with equations. Alright, hopefully you're getting the hang of this. Okay, so I know this was a nice short lesson. Now that you have a couple of examples, I actually am going to have you do numbers 5 through 9. This is not homework, this is classwork. Okay, you are to do this right now. Again, if you have any questions, please raise your hand and I will come over to you.